All right, welcome back, everybody. We're today continuing on our unit on the early modern era with the third part of that unit, which is going to be the first part of our two-part discussion on the Enlightenment. The Enlightenment here. Okay, so roughly, I gave it about a time frame about 1680 to 1800, with some stuff happening before then, and then a few things happening afterward. But a general time frame, the Enlightenment was at its peak probably mostly during the 18th century. So, and there's some really important things to think about. This is some higher level thinking stuff, folks, because I want you to understand a couple of things, right? We talked about the Renaissance and Reformation, and now we're talking about the Enlightenment. So we're moving on to another major milestone and change that happens kind of within the time frame of these other things we've been talking about with the Renaissance and Reformation a little bit. But I want you to understand what we talked about at the beginning of the unit, how you don't get the Enlightenment. The Enlightenment doesn't happen without the previous two events happening, right? Without the Renaissance, without the Reformation. And we'll explain that a little bit more as we go along. But let's get right into it. So some basic facts or some basic background here of the Enlightenment. First of all, the Enlightenment period, which is tied in a little bit with the Renaissance too. It kind of happens as a result of the Renaissance. Brings out a lot of new ideas in society about politics, economics, science, medicine, general life. People start to look at their lives a little bit differently. So let's go back to that idea that I talked about before, right? How the Renaissance and Reformation paved the way for the Enlightenment. Okay, why do you think that is? Okay, so during the Renaissance, people start thinking for themselves a little bit more. People start coming up with ideas. People start to challenge the status quo or the beliefs that that existed for so long that had previously existed. People are challenging that, right? They're becoming unique and different again. We're still living in a society during and prior to the Renaissance where we were, um, depending on the beliefs of Plato and Aristotle from, almost 2,000 years before to give us kind of our understanding of the world around us. The Renaissance challenges that. The Reformation challenges the power of the church, and the Enlightenment's going to blow it out of the water. It's going to challenge old set beliefs even more, right? In regards to the Renaissance and Reformation, how do they pave the way for the Enlightenment? Because, right, people are thinking for themselves now, as they do in the Renaissance, as education improves. People start to get a new idea, a new way of thinking about their religion and faith, which leads to the Protestant Reformation. They just needed a leader in Martin Luther and a catalyst, but then a lot of people jumped on board with this movement, right? Now the power of the church has been weakened. So what we see in the Enlightenment is now, for the first time in forever, the church can't tell people what they have to believe anymore. The church can't tell people what to think anymore about every aspect of life. People are starting to show more independence and thought, and the church is no longer the central authority in people's lives. So we see that as a major, major change for this time. Probably the key figure in terms of world leaders of the Enlightenment is Queen Elizabeth I of England. She ruled from 1558 to 1603. She was the daughter, remember, of Anne Boleyn, who was the second wife of Henry VIII. Her brother was king, and then her older sister was queen for a minute, but she left, and Elizabeth became queen. And it's during this period, 1558 to 1603, that England becomes pretty much the most predominant world power. Okay, particularly in the year 1588. In the year 1588 was an important year in human history because it marked the emergence of Britain as the world's new great power. What happened in this year is something called the Spanish Armada. Now, if we think back to last semester, we talked a little bit about the growth of Spain as this major power in terms of exploration and taking over parts of the world. They were able to do this because they had the world's greatest navy. And during the 1500s or during the 16th century, they were, without question, the world's most dominant naval power. Well, that power was challenged by Britain in 1588 when the Spanish Armada, when the Spanish came and attacked Great Britain, and the British were able to defeat them under the leadership of their admiral, Sir Francis Drake. And it was a big turning point in world history. The Spanish Armada, I'm not going to spell it all out here. The Spanish Armada, S.A. That's terrible. The Spanish Armada was this huge moment that shows that England is now the world's new great power, right? The Spanish Armada to England is the dropping of the atomic bombs to the United States. As soon as we dropped those bombs, the world knew who was boss after World War II. As soon as the Spanish Armada was defeated by the British, the world knew who the next big world leader was going to be. Right? That is the typified period, the biggest moment of the rule of Queen Elizabeth. And in that respect, she's regarded as this very powerful and significant British monarch because of her successes militarily, and the growth of England in general while she was queen. All right, so what we also call the Enlightenment sometimes is the Age of Reason, right? And the key figure in the Age of Reason is a guy named Francis Bacon. Francis Bacon is responsible for creating something called, at least credited with creating something called the scientific method. The scientific method is basically a means for people to come to a better scientific understanding of the world around them. Okay, so make sure you understand that. The Age of Reason, Sir Francis Bacon comes up with, or is credited with the creation of the scientific method, making him kind of the key figure of the Enlightenment, kind of like the Leonardo da Vinci was to the Renaissance. Bacon is to the Enlightenment. The scientific method meaning we come to a better understanding of the world around us using science, hypothesis, synthesis, all the way down to a diagnosis or a final understanding of some new idea or something different. By using reason, by reasoning to make a better understanding of things, people become more intelligent, more thoughtful, and more able to do exactly that, to reason. Okay, and this is a big change and adjustment to see more and more quote unquote regular people being able to reason for themselves and understand aspects about the world themselves. Okay. It's during this time we see a lot of new great philosophers and scientists kind of come from this Enlightenment era, some names that you probably are familiar with. We'll get into most of those in the next video. We're going to talk a little bit about some of the key scientists of this era, though, today. All right? So anyway, the scientific revolution really gives us a lot of new and different ideas about the world around us. We talked on the last slide about Sir Francis Bacon and the Age of Reason. So people are going to start looking at science as a better way to explain the world around them. All right. So we see the arrival of a lot of new ideas about math and science and new ways to express those sort of things. Remember, we had been operating on the beliefs and practices of people like Aristotle and Plato and Ptolemy and Archimedes and Euclid and all those people for centuries. Okay, so now we're moving on to new and different ideas about science and a new understanding again that comes from that, a new understanding of the world around us here. Okay, so who are some of the big figures in this movement? For one, you have Nicholas Copernicus from 1473 to 1543. Copernicus was a mathematician, astronomer, philosopher, and all these things. Copernicus' most notable contribution was his idea known as the heliocentric theory. Heliocentric theory, Heliocentric, heliocentric theory, which states that the sun, not the earth, is the center of the universe. Now, going back to Greek times, we learned this at the beginning of the semester. The Greeks believed that mankind was the center of the universe. Therefore, the single most important element of the universe is mankind. Okay? Copernicus challenges that belief. And what happens when you challenge old beliefs? People don't react to you too well, particularly the church. So Copernicus is convinced not to really go public with this belief, because it would challenge the power of the church and what the church believes. Why is the church so upset? Because the church had adapted to and adopted many of the beliefs of people like Plato and Aristotle, and to challenge those would be to challenge the direct beliefs of the church, i.e., or God. Okay, so Copernicus pretty much keeps his idea to himself until he's about ready to die in 1543, and he goes ahead and publishes this belief in the heliocentric theory, over which calls into question the geocentric theory uh, that had existed for so long, that mankind, or that Earth, was the center of the universe and all the planets, suns, and stars revolved around Earth. Okay, so moving on, you have somebody like Galileo. Galileo comes a little bit later than Copernicus, but he continues Copernicus' work. With Copernicus gone, Galileo becomes the preeminent astronomer and source of information on the sun and stars and all that stuff on Earth during his time. He's considered the father of astronomy in the minds of many people, and he took a lot of heat from the church for talking about and further popularizing Copernicus' theory of that the sun is the center of the universe rather than the earth. The people don't like this, right? The church does not like this. The church threatens Galileo. He has to go into hiding. It's very similar to what Martin Luther went through. Um, but ultimately, because it's the Enlightenment, it's the scientific revolution, people are thinking more for themselves, they're learning more, they're acting in a more educated manner. Um, and, you know, people start to adapt to this idea that it's feasible, right? And, so Galileo gets a little bit of credibility that way. The church still isn't very happy with it. Now, furthermore, Furthermore, Galileo is responsible for the use of the first modern, or well, kind of created the first modern telescope. Um, Many stars and constellations and planets were discovered by Galileo, so his influence on astronomy and science is very, very significant. Now, move on to mathematics a little bit. Sir Isaac Newton is certainly a major, major figure in math. However, um, his new ideas aren't going to quite achieve the level of disdain that the ideas of Copernicus or Galileo did about the sun and the stars and all that stuff. Newton just leads us to a more modern understanding of math, right? Gone now are the ideas of Plato and Aristotle and others that had dominated mathematical beliefs for a long time. In is Newton's concepts of Principia Mathematica, the most important book. Principles of Mathematics is what it translates to, but in the French it's Principia Mathematica, which is basically probably the most important book ever written on math. Um, Newton also, of course, discovers sort of gravity, or at least a better understanding of gravity, and Newton's laws of motion, which again help us to better understand power, force, and gravity itself. Right? What are the three laws of motion? An object at rest stays at rest unless acted upon by an external force. An object at rest stays at rest unless acted upon by an external force. An object at rest stays at rest unless acted upon by a certain force, or an object in motion stays in motion unless acted upon by an external force. Number two is force equals mass times acceleration, right? So force equals mass times acceleration. And finally, for every action, there was an equal and opposite reaction. For every action, there was an equal and opposite reaction. So proportional force, directly proportional to the force applied. We understand motion better this way. This is going to have wide-ranging effects on the world moving forward, and understanding power and movement and things like that. You can articulate, at least to some degree, the importance and understanding of how we're able to make trains and cars and planes later on through our understanding of using motion to move forward at a faster rate. Before, we'd only depended on wind for boats and horsepower and riding horses. Now, new possibilities are out there, and people are going to pursue them in time. Let's talk about medicine a little bit. We also see some significant advancements in medicine. Now, medicine, most beliefs in medicine and our understanding of the human anatomy date back to a Greek physician by the name of Galen, Galen, a physician by the name of Galen. He decided that the human anatomy was largely based on the form of the animal's anatomy, and that's how we kind of made determinations about what the human anatomy looked like. Okay, two important advancements, people that make advancements in medicine during this time. First is a guy named William Harvey. It was long believed, since the time of Galen, it was long believed that the human anatomy was a little bit different, and that blood in the human body, blood flowed through the liver rather than the heart. Harvey disproves that and comes up with a modern understanding of our circulatory system in our blood that helps blood flow through the body, primarily through the heart. Okay, William Harvey comes up with this idea, circulatory system. The blood actually flows through the heart, not through the liver. But you got to imagine that'd be kind of weird for, like, that would mess kind of everything up. If you give people like Valentine's Day, you don't give them hearts, you give them livers. Kind of gross. I don't know, whatever. Then also, another important science figure of the day was a guy named Andreas Vesalius. Vesalius came up with our understanding of the modern human anatomy. How did he do that? Well, he based it off of human bodies rather than animal bodies. Now, Vesalius really put his life in danger by examining corpses of dead human bodies, because they believed that back then it was believed that if you cut open an animal's body, or I'm sorry, a human body, it was desecration of the body, and you weren't supposed to be able to do that. But much better than looking at a cow or some other animal to determine how our own anatomical system worked. So Vesalius took the chance of examining, studying, and better understanding the human body by studying the bodies, the corpses of people that had died, to be able to write stuff down and to better understand just exactly how that works. So these are two major modern breakthroughs in medicine. We're going to stop there today, folks. Tomorrow we'll talk about Enlightenment philosophers, and that will be it for the Enlightenment. See ya.